Greetings to all. Welcome to VMware session. Srinivas here. So, do you have any queries related to previous session? You can raise your hand and you can ask. Yesterday, just a recap, whatever the things we discussed. In first session, we discussed about the demo, talk about what are the things we are going to cover as part of this VMware administration training. The day two, we discussed about before going for virtualization, what are the components, what are the hardware, what is the components are important. There are 5 major components. That's what we discussed yesterday. That is motherboard, processor, memory, storage, and network. And as part of these components, we discussed about the motherboard, how it looks like, and the processor. These two things we covered yesterday. And the important points which we need to remember from this particular yesterday's session, what is socket? From the motherboard, we are, whatever the system we are going to work, that system will be having a motherboard. And that motherboard, all 5 major components, the processor, memory, storage, network will connect. So we need to understand how it looks like and what is from this particular picture, from this particular motherboard, what is a socket? That is what we discussed about. What is socket? What is a processor chip? What is a core? What is a hyperthread? These are 4 components we discussed yesterday under processor. And so today we are going to talk about memory, storage, and network. Why these 5 components are important? As we are going forward, we are going to work on the server hardware. Before going for virtualization, we need to understand what is the server hardware consists. So without understanding the server hardware architecture, it is very difficult to understand in virtualization layer. What is this virtualization layer? By using virtualization layer, we are going to create a virtual servers. A server is nothing but a system. A system is nothing but a combination of 5 major components. If you are not looking at visualize the physical presence of this particular 5 components, you cannot imagine, you cannot think about how it looks like in virtualization environment. Okay, that's the reason we are going to discuss about these 5 components. So do you have any doubts on this particular socket, processor, core, and hyperthreading? Okay, just as whoever joined in this session, if you are new, you can refer the recordings. Recordings are available. If you haven't received that recording information for day 1 and day 2, you can send a mail communication to me on this mail so that I can share that recording links. I'm going to paste that mail ID here on the chat window. You can copy and you can send a mail communication. If you miss any kind of communication, you can send a mail. Okay. So coming back to this topics. So memory. What is important memory? Memory RAM. What is ROM? What is the difference between RAM and ROM? Any idea? Anyone? There is a slight difference. Memory and whatever the memory we are going to talk about, that memory modules, that RAM modules. What is a ROM? This is a random access memory. That is nothing but a memory. That is what memory module you will call it as. And ROM, it is a program. Read only. Okay. You can go through that. Don't get confused. Okay. So memory and RAM. What is a memory and RAM? What is the importance on this particular motherboard where we are going to install? On this motherboard, we identified this particular square box is called as a socket. Whereas in this lengthy ones, on this motherboard, there is a white and black that we are going to call it as a slots. In this particular slots, we are going to install memory modules. Memory modules. What is a memory modules? How we are going to install? What kind of memory modules it will be? See, this is a memory modules. This memory modules ECC error correction check. That is one of the server memory module feature. So this server memory modules having a different sizes of configuration like 4 GB, 8 GB, 16 GB, 32 GB. So why be this difference? For example, if I have on this motherboard, whatever the motherboard we are looking at this particular picture, in this particular motherboard, what is the memory capacity I can install? We need to understand before understanding the server architecture, what are these specifications? So we understand from yesterday's session, we understood that it is socket. We are going to install a processor. That processor is going to have a number of cores. Based on the number of cores, we are going to get a maximum capacity of CPU. Similar way, we are going to talk about memory modules. How much capacity it is going to support? I can install 4 GB memory module. I can install 8 GB memory module. For example, I have 10 slots available on this motherboard. So 10 slots, what is the memory configuration I can achieve? So if I install 4 GB each memory module, 10 slots into 4 GB memory modules, what memory I'm going to get total capacity of 40 GB. Similar way, if the motherboard, that specification, that it is going to specify what is the each memory module supports. Is it supports only 4 GB memory module, or is it supports until 64 GB memory module? If it supports 64 memory module, what it is going to be? What is the total capacity I'm going to get? $640 GB. I'm going to get a total memory capacity. Okay. So if you see what is the memory configurations, memory modules available, these are the configuration after 164. What is the next memory modules? Any idea? These are the memory modules configurations are available based on the server capacity. It is going to configure, it is going to install this respective memory modules. So what we are going to get a capacity according to number of slots, whatever the memory module you are going to install, you are going to get a total capacity of memory. Why we need to go for high-end configuration? As we are going to install virtualization layer on this particular server, we need to make sure in each and every aspect we are going to get a maximum capacity. How to get a max capacity? That's what we need to understand this architecture, how this motherboard, what is the specification of motherboard. We have to say, we have to determine what is the capacity it can support. Is it possible to upgrade? And all those things we need to understand. From where we are going to get understand? By looking at the server model. Okay. Is it clear? Any doubt? This is related to memory module. That's how we are going to get max capacity. So the memory module, each memory module capacity varies in this direction. So again, it is all specification, user manual will be there for the specific hardware. So according to the hardware recommendations, we need to install whatever the memory module, and even you can install combination of different sizes as well. But it is going to specify on which module, which slot we need to install. Okay. So according to module only, they are going to install the respective memory modules. Okay, yes, we are going to work remotely on ESXi host environment, virtualization environment. We are not going to do. The data center operation guy is going to perform this kind of information. But the data center operation guy is a non-technical guy. So it is our responsibility to understand the technical specifications and what is support, and we need to instruct that data center guy, okay, insert this particular module and slot 1. So he is going to install in slot 1. You have to direct, we have to instruct him to what to be done. Okay, so we should have an information what we are going to work. So this is a memory module. So we covered the processor and memory. Next we are going for next topic. Motherboard is done, processor is done, memory is done. Next one is storage. What is storage? What you know about storage? What you know about storage? A hard disk. On your laptop, what type of hard disk you have? On your mobile, what type of storage you have? Generally, in mobile configuration, while specifying the storage, you used to call that as a memory. That is a wrong specification. Memory means it is a RAM. You need to specify properly as a technical person. Generally, non-technical person, everyone says that I have my configuration is 2 GB memory and 64 GB internal memory. So we have to say 64 GB is internal storage. Storage is nothing but where you are going to keep your data. Okay. Now coming to the hard disk and mobile. Can anyone tell me what is a mobile? What type of storage device it is configured on your mobile? You can unmute yourself and speak up. Can anyone? What is a hard disk type? What are the hard disk storage types you know? I hope I am audible.
Sir, there is many type of hard disks, but I'm aware of SDD, SSD, NVMe, and Octal.
Okay. Okay. Very good. So we know the traditional hard disk. We connect the traditional hard disk, external hard disk, and earlier we used to use the pen drive and that SSD. These are the general terminologies we are going to use. For example, a pen drive, if you talk about pen drive, there is a or SSD, there is a specification class 4, class 10. What is that class 4 and class 10? Class 4, class 10. What is that? You purchase a small chip wherein you are going to mention you are going to insert that SD card in your mobile, that it is going to define class 4, class 10 like that. What does it mean? It is a data transfer rate. The data transfer rate, okay? How much data it is going to transfer for a given second, read and write operation. What is that? Read and write operations. So for each and every hard disk, how we are going to measure the capacity, how we are going to understand that capacity of the hard disk. For example, the capacity is a 1 TB hard disk or 2 TB hard disk or 500 GB, doesn't matter. What is the speed it can write, what is the speed it can read, that is a matter while working on server storage. Okay, as we discuss about mobile, we are going to think about class 4, class 10. This is the things you can go through and have a look. But coming to the server, it is all depends upon how speed that it is going to it can write and it can read the data from the storage. That is the specification, important specification while talking about storage. Okay, so yes, we are going to, what is the purpose of storage? First of all, we are going to write the data, store the data. Whenever it requires, we are going to access the data. Okay, for example, I'm working on a single server wherein I'm going to work on that storage and we are going to install some data, copy some data and access some data. Okay, for example, your laptop device is there, laptop storage is there. How fast it is going to write the data, read the data. Okay, it is depends upon how we are going to access the application performance. If the storage is not able to read and write the data in an appropriate manner, that means in a specific time frame, you can see that lagness, that you are not in a position to open that application, or you are not in a position to open the file, whatever you are looking for. For example, you are playing a movie. If the storage from wherever you copy that movie file, while playing that movie file, if the storage is not able to read in a specific speed, you can see that playing video is going to break and play again, break and play again. What is happening in the background? Because it's not able to read the data properly because of less capacity read and write operations on the storage device. So if we are talking about server, we need to make sure there are number of users are going to connect. So number of user, if single user is facing the read and write operation issue, how about number of users are having the issue? The same issue is going to come into picture. They are also facing the same issue. So what we need to make sure, we achieved max processor, we provide max memory. Now we are talking about storage. If the storage is not sufficient capacity, sufficient read and write operations, what will happen? Even if I have the highest capacity of CPU, highest capacity of memory also, if my storage is not able to read as a specification as per requirement, what is the use of having the highest configuration on the server? So I need to make sure what are the storage I'm going to provide. It should be high read and write. It should support high and read and write operations. For example, in SSD, it can support 300 Mbps per second, right? Data, it is going to write the data 300 Mbps for a given second. You can classify what is the type of server storage. Okay, so server storage comes in picture three forms. What is that? DAS, NAS, SAN. Can anyone? What is DAS? What is NAS? What is SAN? Anyone?
The DAS is like the local hard disk we say, or NAS. It's
Okay. Okay, Pooja, please continue.
So NAS is network area storage. So basically, we are accessing data application through a network. And SAN, so it's like through fiber optic channel cable, we are going to access the data.
Very good, Pooja. Thank you. So here, the types of storage which we are going to provide. Why, for example, I'm using server where I'm using direct attached storage. Direct attached storage, the hard disk will connect to that server directly. That means I can call that storage as a local storage. The different types of storage media, SSD, SATA disk, SCSI disk, different types of controllers to support this local disk configuration. For example, my local disk, whatever it is attached directly to the server, if it fails, my file server is running on that server, and every user is saving the files on that local storage. What will happen if the local storage fails? I'm going to lose the data, right? So there the concept comes in picture, how to make it the storage available even to avoid single point of failure. That is the concept comes in picture, shared storage. Shared storage in the sense it is can be configured over the NAS, that is network area storage, or SAN. What is the difference between NAS and SAN? For each and every storage, there is a advantages, there is a disadvantages. For example, local data store, local storage in the sense, we are going to get a highest speed. But what is the disadvantage? It is a single point of failure. If something goes wrong on local storage, I'm not in a position to access the data. I'm going to get a max capacity, max speed, max read and write operations. But only disadvantage is it is a single point of failure. If the server can be failed, the motherboard can be failed, or processor can be failed. If whatever the issue it is going to happen on that server, I'm not in a position to access that data if it is local. Whereas in NAS, it is a shared storage, one of the network area storage, wherein the storage server, it is going to provide, share the storage to the clients. Who are the clients? Whatever the server, whoever what may be accessing the centralized storage, that is a shared storage. What interface it is going to access? It can communicate over the network. That means existing network. Already existing network is there. Number of servers are connected together to establish communication, to share the data. Now the same network can be configured and can be used as a centralized storage, that is a shared storage. So in this particular server configuration, whatever we are going to talk about, it requires a shared storage. So how it is going to benefit? Okay, what is the speed we are going to get? What is the advantages? We are going to avoid single point of failure, and it is going to use existing network infrastructure, and we are going to fulfill all users can store the data irrespective of local system. Centralized data saving will be there. You can access the data from anywhere location. That is NAS. What is a SAN? We are going to get a max speed, max bandwidth, higher data read and write operations. The only disadvantage here, it is very expansive infrastructure. What is expansive infrastructure? It works, we need to lay down fiber optic cables. We cannot use existing network infrastructure. So the storage server will be connected, should be connected to the fiber optic underlying architecture. So by using fiber optic underlying architecture, it is going to send and receive the data. We are going to get a maximum read and write operations, higher speed compared to NAS, but only disadvantage here, it is very expensive. Generally, all enterprise environments wherein they are going to configure the storage server on fiber optic. That means they are going to use SAN environment to get a max performance. As we are already discussed about processor and RAM, we achieved max capacity to fulfill entire server requirement. At the same time, whatever the storage is we are going to provide, that storage should be in a position to fulfill max read and write operations. We should avoid a single point of failure, and then it should be redundant and durable, so accessible and from any location. So according to organization requirement, they are going to design how to provide the storage to the server. Okay. Is it clear? Any doubt? So we need to understand only from the storage, we need to understand what we need to make sure. Maximum read and write operations, less latency. There is a latency concept. Latency is nothing but the interruption to the read and write operation. What is the latency we talk about? Higher latency in the means there will be an issue on the operations, read and write operations. So it should be some latency measurement will be there. According to requirements, we need to fulfill. Okay. That is a latency for a network. It is somehow latency information. For fiber, there will be some latency, minimum tolerant latency. Okay, what is a minimum latency for local? Some latency will be there, some numbers. For everything, it has to be configured, it has to be fulfill the organization requirements to get a desired requirements. Is it clear? Any doubt? The storage. So how we are going to get a storage? We are going to get storage. See here, hard disk, whatever the hard disk, the storage server is going to connect in different disk controllers, PATA, SATA, KC, SSD, etc. different types. Even latest technology, NVMe, that is the latest storage media, which can provide higher read and write operations. Okay, so server storage types. What is we discussed about DAS. DAS is nothing but it is the direct attached storage. Whatever the disk it is connected to the server directly, that is nothing but a DAS, that is direct attached storage. Whereas server storage types, what is the server storage means? Centralized storage requires types, centralized storage types, that is NAS and SAN. Okay, so we already discussed about NAS requirement. Can be used existing network infrastructure to fulfill the centralized storage requirements. Whereas in SAN, what is required? It is going to run on a fiber optic cables, and fiber optic infrastructure has to lay down to incorporate the SAN requirements. So what is this? HBA card. For each server to establish SAN communication, there is a separate card is required. That is nothing but a host bus adapter. What is it? For SAN communication, it is host bus adapter. HBA card. How it look like? This is HBA card wherein we are going to insert fiber optic cables to this particular card and to establish SAN communication. Okay, this is a specific card should be available on storage server as well as the client system so that it can communicate and to the SAN storage server to get the desired storage. Okay, so why we are going to understand this entire requirements, it is we are going to work on virtualization layer, how this entire infrastructure, the 5 major components are going to connect together to fulfill the requirements of the virtualization layer. Okay, so this is all about storage. Any doubt? What is the storage? Different types. Okay, now the important component, that is final one, that is network. What you know, network. Generally, network is nothing but local area network, right? What are the servers we connect internally? That is, we call it as local area network. To establish local area network connected, I have 10 systems in my environment. I have 10 systems. I need to establish communication from 1 to 1. What device it is required to establish communication? I have 10 systems. What are the components are required from the client and to server, and what is the intermediate devices? What are the components are required? Can anyone?
Sir, for internal connection, we need a switch or IP address, NIC card, router, all those things.
Thank you, Pooja. Hope you are aware of NIC. What is NIC? Network interface card. I can call it as Ethernet card. Without Ethernet card, we are not in a position to establish. The same NIC card should be there on every system. I have 10 systems. In the sense, on those 10 systems, I should have the NIC card. That is a network card. What is that port? It is the network card is going to have a port. What is that port? We call it as. Any idea? What is the difference between hub and switch? How we are going to connect from switch to system? What we are going to use? So in the network configuration, we need to understand what is the components involved in establishing communication from one system to another system. In an enterprise environment, you might have 100 plus systems or 50 plus systems, doesn't matter. We need to understand how the systems are communicating one to one. So what is the minimum requirement we should have? The system which we're looking for communication, the system and the destination should have the network card. What is that network card? Network card is nothing but it looks like the same in this picture. What are the network card? It is there in each and every laptop. You can identify a port wherein you are going to connect a cable. What is that cable? It is a Cat5 cable, Cat5, Cat6 cable, right? So what we are going to do, we are going to insert that Cat5, we are going to insert that cable in a port. That port, what is that port? We call it as RJ45. Okay, that port, what is the port? It is a RJ45 port. Okay, for each and every network interface, whatever the port it is going to have, that port we call it as RJ45 port, wherein we are going to insert the cable, and one end it is going to insert in the network card of the system, other end it is going to connect to that switch. Okay, why we are not using hub, why we are using switch? Can anyone? What is the difference between what is a hub and what is a switch? First of all, this is a basic information which we should know as part of VMware administration, because we are going to work on basic components like network infrastructure. We are going to establish storage, we are going to establish processor, RAM, everything, these 5 major components to each and every virtual server. What we are going to assign? We are going to create a server. What is a server? Server is nothing but a component, 5 components: motherboard, processor, RAM, network, and storage. How we are going to provide? So we need to understand what these components physically look like. Without understanding physical visualization, you cannot imagine how the virtual things are going to work. Okay, so coming to the network. So whatever the systems are connected in a specific network, we call it as a local area network. Okay, so what are the components in it involves? The network card and the switch and the cable. It is going to establish communication. Now, what is the difference between hub and switch? The simple thing is that you can Google it and understand what is a hub and switch. Hub is just if you go to any internet center, they are going to use the hub device as to establish communication. 5 systems or 10 systems, one-to-one communication. So what it is going to do, we are not in a position to manage the network traffic, the packet travel, we cannot manage. Whereas in switch, it is an intelligent device wherein we can manage the configuration of the switch to restrict the packet travel, the packet bandwidth. What is the bandwidth we talk about here? Generally, you purchase the internet. For example, you are accessing internet over your mobile. What is the speed you are getting? How much data package you purchased from mobile device or internet router or internet home? What is the bandwidth? 100 Mbps, 30 Mbps. How they are going to restrict this bandwidth speed? For example, if you pay 300 rupees, you are going to get 30 Mbps speed. If you pay 1000 rupees, you are going to get 100 Mbps speed. How they are going to restrict this bandwidth? They are going to restrict the bandwidth by using this particular switch. Whereas in through hub, it is not possible to manage the bandwidth. Okay. Here in this, what we need to understand, what is the network card speed? Because every packet is going to travel from one system to another system over the NIC card. So I'm talking about the server. We already discussed about processor, memory, storage. Now we are discussing about network. So previous all 3 components we maintain at a higher capacity, higher configuration to meet the server requirement. Generally, NIC cards will be there. What is the NIC card speed? If you notice, have you noticed NIC card speed? If you go to on your internet Wi-Fi, you are going to get a Wi-Fi speed. What is the Wi-Fi speed? What is the local area network speed? Generally, in our laptops, we are going to get 1 Gbps network card. But whereas in coming to servers, we are going to have different speed, 1 Gbps, 10 Gbps. I'm mentioning one letter in uppercase, remaining in small letters. It is a technical specification. You should not miss this configuration while mentioning. Okay. So this NIC card on the server, if I talk about, if I go with, for example, even NIC cards older days, NIC cards are well configured 10 Mbps also, 100 Mbps also. If my server is everything is on a high end, if I install NIC card as a 10 Mbps or 100 Mbps, will it fulfill my requirement? If there are number of users are going to connect to the server, storage is high end, processor is supporting, memory is supporting. If the network is not supporting, what is the use of having that much high-end configuration? So that's the reason I'm keep on stressing here. Whatever the 5 components we are talking about, each and every component should support max capacity, max ratings, max performance. So what we are going to achieve, what card we are going to insert, what storage we need to connect, what processor we need to install on the server. We need to make sure everything supports max performance. So out of this, to get a max performance, which card I'm going to use? I'm going to use 10 Gbps card. Is it clear? Any doubt? This is an interactive session. You need to speak up. You need to clarify your doubts. Okay. If I keep on talking, it is not going to help you guys. You are going to learn the subject. You need to understand from the scratch. I'm here to provide each and every depth of this topic. It is your responsibility to learn and adopt the technology and explore in a different directions. Okay. So now we discussed about all these 5 components. Now we are going to look at what is a server models. Server models. What are the server models? There are tower servers, rack servers, blade servers. Server models, basic classification looks like what is a tower server? What is a rack server? What is a blade server? Okay, most of the enterprise VMware infrastructure runs on blade servers. Now we need to understand what is a blade. Okay, in existing environment, some servers are still running on the infrastructure wherein rack servers are using. We are going to work on a lab environment, and that lab we have the rack servers. Now we need to understand how it looks like. What is a tower server? What is a if you see here, the normal desktop, what you have at home, it is a tower model. And box, it is going to stand and sit on your desk. That is nothing but a tower server model. Okay, for each kind of server model, it is going to fulfill certain requirements. Okay, generally tower servers are used in a storage application, storage server configuration. Why? Because it is going to have an ability to insert number of hard disks so that this tower server can be configured as a storage server. For example, my environment is going to have 100 servers, physical 100 ESXi4 servers, for example. If I'm going with the tower server, how much space it is required? I need at least 5 to 10 rooms, or one building is required to place this kind of tower server in a building, 100 servers. Okay, for example, if I go with this one new rack server, see how sleek it is. This rack server is going to insert in a model in rack enclosure. What is a rack enclosure? This is a rack enclosure in the data center, which we can look at this kind of rack enclosures, different types of rack enclosures, wherein this particular rack server, why this rack server? This server, this architecture is going to insert in the rack enclosure, where we are going to insert this rack server in that particular enclosure and connect the cables. Okay, so this everything, all these types, all three types are going to have these 5 major components. What is the 5 major components? Motherboard, the processor, and RAM, storage, network. These 5 components is nothing but I'm calling as a server. Okay, what type of server? Different types of server models: tower server model, rack server model, and blade server. What is the advantage of blade server? Why it is industry leading architecture? Whatever the virtualization vendors, all the virtualization vendors are preferring to run their environments on blade server. What is the advantage? I mentioned that if I go with 100 servers of tower servers, how much footprint it is required? It is going to occupy at least 5 rooms. That 5 rooms, I need to make sure power connections, I need to make sure power cables, AC requirements, and all those things. Whereas in rack enclosure, the same 100 servers, I can deploy this kind of rack enclosures in 1 room or 2 rooms max, so that I can restrict from the tower server to rack servers, reduce the footprint of the occupation, the building infrastructure, AC requirements, power requirements, and all those things reduced while discussing about tower server to rack servers. Now, what is about blade enclosure? This blade enclosure, blade chassis or enclosure, you can call it as anything, blade chassis. What is this blade chassis? Blade chassis is just like a one more enclosure. If you see here, this particular enclosure, how many blade servers are inserting one small enclosure? Chassis. This is a chassis, we call it as. Okay. See here, in this particular chassis, we can insert 16 blade servers. How many? 16 blade server. This, whatever the server it is came out, this is, we call it as off height, off portion. Okay, that's the reason we are going to showcase here off height blade server, full height blade server. In the same enclosure, this server, whatever the architecture it is available here, if you compare with the rack server, the rack servers are capable to fulfill certain requirements. In this one new rack server, if you see how many hard disk I can insert, I cannot use this one new rack server for storage application because there is no provision to insert number of hard disks. That's the reason this one new rack server I cannot use for storage specification. So what is the storage server requirement? It should have maximum base wherein I can insert maximum hard disk. See, this 4U rack server is going to have a maximum base wherein I am going to insert number of hard disks so that I can use this rack server as a storage server. Coming to this blade server, it is only designed and solution is requirement is fulfilling requirements for only virtualization environment, because it is not going to have number of base. By default, it is going to have only 1 or 2 base. That's it, to insert a local storage. So blade servers are not meant for storage servers. So what type of storage, what type of server you are looking for, based on that you need to choose the architecture from the available. So back to this blade enclosure, I mentioned that this blade enclosure has one enclosure. It's just like 8U or 10U size. Within the 10U size, I can insert, if it is a off-height blade server, I can insert 16 servers. If I full height means from the top to bottom, one blade server I can insert, that full height. 8 servers I can insert in one chassis. Again, this chassis is going to sit in this particular rack enclosure. How many chassis it can insert? 4 chassis I can insert in this rack enclosure. 4 into 16. How many servers within a one rack server? 64 servers I'm going to achieve from one rack server. Imagine how powerful it is. So I'm going to reduce the power print. The advantage of the blade server architecture, it is not going to have cables. That is a beauty. Here for tower server, I need to connect power cable. I need to connect display cable. I need to connect keyboard, mouse, and network cables, storage cables. All those things I need to connect. Okay. For example, I'm using either one of these 3 picture in a rack enclosure. For example, I'm taking this 4U rack server. In the same rack enclosure, I'm going to insert these 4U rack servers. How many? Maybe 6 servers I'm going to install. How many cables are required? 6 power cables, 6 network cables, 6 storage cables, all those things. Coming to this particular blade server, it is not going to have any connectors. What it is going to do in this particular enclosure, in this particular chassis, is going to have only one power cable, one network cable, one storage cable to fulfill all these requirements. There is another specification to maintain redundancy. How to maintain redundancy? I'm going to talk about what is redundancy. Okay, but as a server architecture in virtualization layer, most of the environments running on the blade servers, high-end blade servers. Is it clear? Any doubt? Any clarification? Today we discussed about the 5 major components, that is motherboard, processor, memory, storage, network. Once all these 5 components are done, we discussed about server models. Server is nothing but it is going to have these 5 major components. According to specifications, it is going to have. Okay. So what is our environment in the lab? What we have? We have Dell PowerEdge R630. Dell PowerEdge R630. This is a rack server. What we are looking at, Dell PowerEdge rack server. See here, it is a 2U rack server. If you want the specification, you can go through the specifications. What is the server? What is the form factor? Everything it is going to provide complete information. Okay, how it is going to provide support and all those information it is going to spread. Complete information is available in this particular Dell R630. One more model what we have in this lab environment is that is Dell R820. That is again one more rack server. Okay, so this is a rack server which we are going to provide in our lab to access this lab environment, and you can do hands-on practice on this kind of servers. Once you are familiar with this server physical infrastructure, you can work on any kind of physical infrastructure. This is a rack server. If you know what is a rack server, what is a server, how you are going to access remotely, if the same principle, the same basic concept will be applicable to for HP servers, for Lenovo servers, for Cisco servers, any server. We are going to connect and we are going to understand what is the specification, how many sockets are there, how much memory I can install, what type of storage is available, what is the network capacity, all those things for each and every server model according to the specifications. Okay. Once we have the server model, I'm going to get a complete information. If you are working on a real-time environment already, you can review what is the server model and go through the specs by looking at that. For example, if we have that server, Cisco server, you are not sure it is a blade server, rack server, whatever it may be. Just mention that model you can find from the inventory. Okay, B230, B230M2. What is this? By looking at the information, I can say this is one of the blade server. Okay, I know the model. That's the reason I mentioned here. If you are not sure, you can get that information from your inventory and understand that specification of each server. What is the CPU capacity? What is the memory capacity? What is the minimum? What is the max? These two things we need to understand by looking at the server model. Okay. If you have the server model, what you can get it is, you can get manual also. In that manual, it is a clear information will be available how this motherboard and how these connections I have inside the server. For example, if I'm opening this blade server PDF file, this is a typical blade server, how it looks like. Inside, what is the panels are available, what is the controllers are available, everything manuals available. You no need to look at that. But first we need to visualize. How can I visualize? The videos are available in YouTube. Okay, it is very much important to understand visualization. If you understand visualization, then only you can replicate in virtualization, imagination. Okay, clear? So you can understand by looking at this picture. See here, inside this blade architecture, the motherboard laydown. How many processors are available? Inside Cisco UCS blade server. See here, DIMM slots, CPU, adapter card connector, CPU1 heatsink. So all these things, by looking at that, if you don't understand what is a motherboard, you can't understand what is DIMM slots. Okay, now you are a technical person. Now you understand what is a motherboard. By looking at this diagram, you are able to understand what is the DIMM slot, wherein we are going to install memory modules. Hope it is clear. Any doubts, any clarification before closing the session? So this is the CPU models it can support. If you just go and understand E72870, what is the processor? E72870. E72870. The processor configuration complete specifications we are going to get. This is the information what we need to understand from your existing infrastructure. Okay, it is a practice. We need to understand each and every component. Okay. Okay, that is all for today. If you know other queries or concerns, we are good to close the session. Before closing the session, final call, any queries, any questions? Okay, then silence I'm taking as no questions. Okay, have a great day. See you next session. Bye.
Thank you, sir.
Thank you all.